All right, everybody, so Miss Deer back on the mic yet again. And I just wanted to go over an example of an iterated integral for you and sort of how this works. So I picked an, I am, is that okay? So I picked an example from your book so that hopefully you can see how they did it and hopefully my explanations help you a little bit more. So in the example of finding a change of variables, this is example 2 on page, wait for it, 1046. You're given the equations that bound the region. The equations are, I'm looking at the book right now, x minus 2y equals 0, x minus 2y equals negative 4, x plus y equals 4, and x plus y equals 1. So if I'm going to try to switch this to being in terms of u and v, you can see, hopefully, that the easiest sort of conversion here is to let either u or v be this one, and let either u or v be this one. So if I let u be x plus y, then u is between 1 and 4. And if I let v equal x minus 2y, then v is between negative 4 and 0. And you can see in the book that when you sketch these in terms of x and y, if x is 2y, that looks like this. And 2y is negative 4, that's up here. X plus y equals 1, that's going to be here. X plus y equals 4, that's going to be up here. So this is this terrible region that's neither y simple nor x simple. So when I switch to u and v though, well, you can see simply that my u values go between 1 and 4. My v values go between negative 4 and 0. So I have this really simple rectangular region. And again, remember that if we're going to find the area, that's going to give me the same area. So let's define a function. Let's say f is bounded and defined over R. And let's find the double integral over R of xy dA. So what we need is x and y in terms of u and v. And so here we end up having to do a little bit of algebra. I know we all love doing algebra. So if u equals x plus y and v equals x minus 2y, well, then I know that, let's see. So let's say here, let's solve for x first. X equals u minus y. So I'm going to need to define x in terms of u and v, which means I need to get y in terms of x and v, because that's the missing variables here. So if I want y in terms of x and v, 2y equals x minus v, y equals x minus v over 2. Zoop. I can just stick that right in there. So x equals u minus y, which is x minus v over 2. I'm pretty lazy, so I would go ahead and multiply here everything by 2. So 2x equals 2u minus x plus v. 3x equals 2u minus v. So x equals 2u minus v over 3. I am partway done because I have a lot more algebra to do. I need to solve for y. So now I have x. Now I need to find y. So now I have, let me see this. So I have v equals x minus 2y. I have x equals u minus y. So v equals u minus y minus 2y. So this is u minus 3y. So 3y equals u minus v. Y equals u minus v over 3. So I have x equals 2u plus v over 3. I have y equals u minus v over 3. Now we need to find my Jacobian. Again, remembering this is going to be the partial with respect to u, the partial with respect to v, the partial with respect to u, the partial with respect to v. So let's see what I get here. I literally get to take some derivatives. So the partial derivative of x with respect to u is 2/3. The partial of y with respect to v is negative 1/3. Minus the partial of y with respect to u is 1/3. And the partial of x with respect to v is 1/3. So I get negative 2/9 minus 1/9, which is negative 3/9, which is 1/3. So this is going to be my Jacobian that I'm going to stick into my double integral. So I have the double integral of, well, what was my function I gave you? Was it xy? I believe it was xy dA. So now I'm going to turn this into the double integral of x, 2u plus v over 3, y, u minus v over 3, Jacobian. And now I have du dv. And if I look at my u values are in the inside. My u values go from 1 to 4. My v values go from negative 4 to 0. I put those on the wrong integral because I'm not perfect. So my u values go from 1 to 4. My v values go from negative 4 to 0. And now you probably never thought you'd say this, but we have a really easy double integral that we can evaluate. All right, so hopefully this explains some of the missing work. I know your book doesn't exactly explain all the algebra. Hopefully this gives you a really good clue as you work through the problems.